Welcome to qnawire.
We want to give expressions to represent all the exact solutions to the equation. Let's go, well, we could do this with a calculator, for instance. You do have to be careful using a calculator. To do sine squared, you have to do 2 sine of x, but then that needs to be quantified so that you can square it. That's what sine squared x would be. Minus the square root of 3 times the sine of x. We want to know, when does this equal 0? Well, it equals 0 at 0. At pi over 3. Two pi over 3 pi and then it repeats at 2 pi. So the period of the cycle is 2 pi. So that's the period of the function. So within one cycle, we have 4 solutions: 0, pi over 3, 2 pi over 3, and pi. So the way we would use n as a general integer parameter would be basically 0 plus and minus 2 pi n, because you can go, if the period of the function as a whole is 2 pi, then we can add and subtract integers of n. So pi over 3 plus or minus 2 pi n, and 2 pi over 3 plus or minus 2 pi n, and pi plus or minus 2 pi n. In 2019, the population of a colony is 13,000 and is decreasing exponentially at a rate of 1.4% per year. If we use the exponential model for decay, it'd be 1 minus the rate to the time, since it's per year. So if it's 13,000 now, and it's decreasing at 1.4%, that's 0.014 as a decimal. We want to know, what will the population be in the year 2029, which is 10 years later. So we would plug in 10 for t. So that'd be 13,000 times 1 minus 0.014 to the 10th. If we round this to the nearest person, that'd be 11,290. And what year will half the population be left? Well, half of 13,000 is 6,500. If we solve for t, divide by 13,000 to get 1/2. Then take the log or the natural log of both sides. I'm going to take the natural log. So the natural log of 0.5 would equal t times the natural log of 1 minus 0.014. Then just divide by the natural log of 1 minus 0.014 to both sides, and we've solved for t. So natural log of 0.5 divided by the natural log of 1 minus 0.014. And if this comes off of the year 2019, then we would just add 49.1 years to it, and it would be in the year 2068.